When we're thinking about a problem where we're trying to solve trigonometric equations, and we have something more complicated on the inside of our trigonometric equation, like on this one, we have 2x. So that's making this a little bit more complicated as far as solving it down. So let's think back. If instead of a 2x on the inside or anything more complicated, what if we just had theta? So let's say we were trying to solve down cosine of theta equals 1/2. And this is how you want to think about them as well. If we wanted to solve this, hopefully we think to ourselves, okay, 1/2, that's a nice ratio. That comes up a whole lot. We're thinking to ourselves, theta is going to be pi over 3. All right, if we plugged in a pi over 3 into cosine, it would produce a positive 1/2. Okay, and then we would also want to go ahead and add plus 2k pi or 2 pi times k, where k is some integer. And 2 pi is going to be the period for cosine. So that's one way to format our solution to this. We can also get an additional solution if we kind of keep in mind cosine is going to be positive in two different quadrants. I use the phrase all students take calculus to remind me. Everything's positive. All of the trigonometric functions are positive in the first quadrant, only sine in the second, tangent's positive in the third, and cosine's positive in the fourth quadrant. So what I'd like to do is use this pi over 3 as a reference angle into the fourth quadrant and find some angle that'll be in the fourth quadrant that'll also have positive 1/2 coming out when I plug it into cosine. So what I'm going to do is just draw in, I'm going to use a reference angle of pi over 3 into the fourth quadrant. Now our goal is calculate this angle that goes all the way around into the fourth quadrant that has pi over 3 as a reference angle. So to do that, I know it's going to be 2 pi to go all the way around the circle. So to calculate this additional angle, I would say theta has to equal 2 pi minus the pi over 3. Instead of going around all the way, we want to take away the pi over 3. So our angle that lands in the fourth quadrant is going to land right here. A little bit of calculation going on here. We can say, well, instead of 2 pi minus pi over 3, maybe we rewrite that as 6 pi over 3 minus pi over 3, which would equal 5 pi over 3. So that's another angle that when I plug it in for cosine, it's going to produce a positive 1/2 coming out. So let's also go ahead and rewrite it. So we can say theta is going to be 5 pi over 3 plus 2k pi or 2 pi times k, where k is some integer, either positive or negative. All right, so that would be the solution to this equation where cosine of theta equals 1/2. Ours was slightly more difficult than that. It was cosine of 2x is equal to 1/2. So next what I'm going to do is I'm going to replace my theta with 2x. So we can say our solutions are going to be 2x equals pi over 3 plus 2 pi times k, or 2k times pi. And then our other one can be represented as 2x is equal to 5 pi over 3 plus 2 pi times k. Now the problem here is we don't quite have x on one side by itself on either one of these equations. So we need to do a little bit of work and isolate x. So in this case, all we need to do is get rid of that multiple of 2 that's out in front. So what I'm going to do is go ahead and divide the left-hand side by 2. Since we do have a fraction over here, it may be easier if we just multiply by 1/2. That's equivalent to dividing by 2. And then that last fraction, I'll make this into a fraction by dividing by 2. So we're doing the same thing to each term on the left side and the right-hand side. We're either dividing by 2 or multiplying by 1/2, however you want to visualize it. We'll do the same thing over here on this other angle. And what we're going to get is x all by itself. And we're going to have x is equal to pi over 6. Plus, we can simplify this down, canceling out 2's if you like to visualize it that way. And we have pi times k. Over on the other equation, we're going to have x equals 5 pi over 6 plus pi times k. Again, those 2's get to simplify down and make a 1 over here. So this is how we would represent all of our solutions to this equation. Would be just write out these two as our solutions. However, On ours, we're isolated in between 0 and 2 pi. We want all the solutions in between 0 and 2 pi. So how we get those is we're going to basically go ahead and fill in a couple integers for k. All right, the first integer I'm going to fill in is going to be k equals 0. So as I fill in k equals 0 into this left equation, we get x equals pi over 6 plus pi times 0, which is just going to give us pi over 6. And then very similarly on the right-hand side, we have 5 pi over 6 plus pi times 0 is going to be 5 pi over 6. These are two solutions. They both fit in between 0 and 2 pi, but there may be more. Here's how we tell if they're going to be more. We plug in different integers. So let's try plugging in k equals 1. So in this case, we have on the left-hand side, we get x equals pi over 6 plus pi times 1, which is, again, just pi here. And then a little bit of simplifying down, we can go ahead and say, well, I want a common denominator. So I'm going to write that 1 pi as 6 pi over 6. And we're going to get 7 pi over 6 as our solution. Again, 7 pi over 6 fits in between 0 and 2 pi, so that's a good solution. Let's do the same thing by plugging in a 1 to this right equation that we got to. We can say x is going to equal 5 pi over 6 plus pi times 1, or that can be thought of as 5 pi over 6 plus 6 pi over 6 is going to be 11 pi over 6. Again, 11 divided by 6, just slightly smaller than 2. So this is still fits in the correct range between 0 and 2 pi. So two more solutions. We may think to ourselves, what happens if we plug in a 2 for k, right? We plugged in 0, plugged in 1. If you plug in 2, we're going to get 2 pi at the end being added to something positive. Same thing's true over here. We have 2 pi. If we plugged in a 2 for k plus something positive, that's going to be outside of this range. That's going to be larger than 2 pi. So that's not going to be a good solution. All right, so follow these same sort of steps. As long as you have something different than just cosine of a single angle on the inside here, and this doesn't have to be a 2 times x, this could be pi over 6 times x or something else on the inside here, I would approach it in the same fashion. So I hope this helps as you're working on solving trigonometric equations. Good luck.